Good afternoon, Dr. Joy and Dr. Mark. My name is Jay Corbett, and today I would like to present my final project. The title is Mercury Reduction by Micrococcus species, isolated from Sydney Island, Antarctica. Here's the outline of the presentations. As an introduction, the mercury has been extensively used in technological development in the human history. But despite its practicality, the mercury is also known as a very toxic element. And aside from its toxicity, the mercury also have the nature of the bioaccumulation and the biomagnification, which have a significant impact on both human health and the environment. So looking into the past case study of the mercury poisoning, so Minamoto disease, which happened in the 1950s in Japan. So Minamoto disease is a neurological disorder caused by the mercury poisoning due to the illegal discharge of the methyl mercury from the fertilizer production company. So as a result of Minamoto disease, there was a significant impact on both human health and local communities. And after the 70 years from the incident, people are still fighting with the government for the compensation. So that's how powerful the Minamoto mercury poisoning can become. So now looking into the more present case study, artisanal small-scale gold mining, also known as ASGM, Indonesia. So Indonesia, gold extraction is a major industry, and when they extract gold from the environment, they use the mercury to extract the gold from the environment. So after they use the mercury, they should dump into the environment because these places are usually illegal and also small scale. Then once the mercury enters the environment, it goes into the food chain and it started affecting the local communities. So as I mentioned, in these places, usually it's illegal. That's why, although we have the conventional technology to remove the mercury from the environments, we need something more simple to solve this problem. So today I would like to propose the mercury bioremediation as a potential solution to these mercury pollutions. So mercury bioremediation is a microorganism to remove the mercury from the environment. And this can promote a sustainable and eco-friendly practice for the mercury removal from the environment. So looking into the mechanism of the mercury reductions by mercury reductase bacteria. So the mercury can exist as organic or inorganic mercury in nature. And once it goes into the mercury reductase body, it will be transformed into the mercury 2 class with the help of the mercury gene. And with the help of the mercury gene, it becomes an elemental form of mercury, which is mercury 0. And the mercury 0 is volatile at ambient temperature. And once it goes in the atmosphere, it has a long retention time, which allows the long-range atmospheric transports. And as a result, the mercury will be deposited to the far remote areas, such as Arctic region and Antarctica. And indeed, Antarctica is one of my main interests in this research. So here's the literature review. I extensively studied the mercury reductase bacteria from the past year study, and I studied about such as mercury reduction, mercury tolerance capacity, and also the sample origin and the sample media. So here's the research objective. There are three. The first is to determine the mercury tolerance level, and the second is to assess the mercury reduction capacity of micrococcus species, and the third is to determine the reduction rate of mercury concentration by the regression analysis. So here's the research background. In order for me to say that this bacteria can remove mercury from the environment, first I need to identify a gene from the potential bacteria. And once they have the gene, I'm going to run I can run the laboratory experiment to know more about the capacity of this bacteria, and eventually go into field experimentation. So prior to this research, the past year study done by Mr. Vijaya in 2021, he found the mercury gene, which is responsible for mercury reductions from the micrococcus species isolated from Sydney Island, Antarctica. So the ultimate goal of this research is to investigate the potential of the micrococcus species as mercury reducing bacteria. So at the end of the presentation, I should be able to answer the simple question: is micrococcus species mercury reducing bacteria? With yes or no. So here's the methodology. Based on the three objectives, I constructed three methodologies. The first experiment is to assess the mercury tolerance of micrococcus species. So I use the Kirby dilution disk method to determine which concentration can micrococcus species survive. So first, I grew the bacteria on agar plates, and after the incubation and bacteria growth, I introduced the mercury with the antimicrobial disk. And after another incubation, I can see whether the presence of mercury at a different concentration inhibit the activity of the bacteria. And the second experiment is to assess the mercury reduction capacity of micrococcus species. So research question here is how much mercury can how much mercury can micrococcus species reduce. And here I use the gross method. First, I prepare the nutrient gross media containing the different concentrates of mercury with the preparation control. They are inoculated the micrococcus species and incubated using shaking incubator. Then after the incubation, I collect the few ml of sample and then run the centrifugations. And step 2, separate the liquid and the solid component of the sample. So now I have the two samples before and after the incubation. Then I send this sample to the ICP-MS laboratory to analyze the mercury content. And compare the before and after, I can see whether the mercury reduced or not. So moving to the results and discussion. The first finding is that I determine the mercury tolerance of micrococcus species. So I use the minimum inhibitor concentration to determine the mercury tolerance level of this bacteria. And I found that minimum inhibitor concentration of micrococcus species 100 milligram per liter. The question is whether this value is good or not. And this is a literature review. And then look at the MIC part. It shows the tolerance capacity of micrococcus species. Sorry, it's a very big graph, but the main point here is that according to the previous study, the most of MIC is below 100 milligram per liter. So looking back to my result, so this 100 milligram per liter is quite good result. Another finding here is that in most of the bioremediation work, it's often gram-negative bacteria used because of the more reduced structure of the cell wall. But this micrococcus species is most likely to be a gram-positive bacteria, giving the perspective that this might attribute to the harsh environment in Antarctica, may develop the bacterial tolerance to higher level because in Antarctica, organisms exposed to many challenges such as UV light, cold temperatures, and also the Antarctica is also known as natural pool of the mercury for millennia. So here's the second finding. I determined the mercury reduction capacity of the micrococcus species. So the figure shows the mercury reduction after 72 hours of incubations at the different initial mercury concentrations. So from here, I saw the significant mercury reduction percentage at a different concentration of 109, 150, and 168 milligram per liter. So as you can see in the figure, there's some inconsistency of data opposing general trend of the mercury reductions. Because by general theory, if the initial mercury concentration increases, the more bacteria will be, more bacterial activity will be inhibited by mercury. But it constantly shows the consistent level of reductions. So it gives the two possible explanations to this. The first is the experimental error, I made some mistake. And the second is that the unique origin of micrococcus species from Antarctica, where the mercury might enhance the bacterial activity to a certain degree. So maybe if you increase the concentration, I can see the reduction of the percentage reductions. So moving to the third finding of this research. So in the first finding, I know that the mercury can tolerate, bacteria can tolerate the mercury. The second experiment, I can know that mercury can reduce, bacteria, micrococcus can reduce mercury. And in the third finding, I conducted the regression analysis based on the second experiment result. And I found that the micrococcus species have the ability to reduce mercury concentration, even at the high concentration of the mercury. So these presented results suggest that micrococcus species, isolated from Antarctica, is a promising candidate for the bioremediation in the mercury contaminated sites. So moving to the fourth finding, bioobservation. So after the incubation of the nutrient growth bacteria and the mercury, there's a black colored byproducts observed after incubation on the flask. So this is possibly assumed to be a mercury sulfide according to the assumption of the previous study. So this actually contradicted the common theory of mercury reduction by mercury reduced bacteria. So by common theory, when the mercury is reduced, it becomes volatile and goes into the atmosphere and then removed. But in this study, if this is a mercury sulfide, they didn't go into the air, they actually stuck on the surface of the flask. So in a real scenario, it might not go into the atmosphere and it might deposit on the nearby shore. So that's kind of bring a new perspective in the mercury bioremediation work. So here's the conclusion. So I investigate the potential of micrococcus species as mercury reduced bacteria. So there are three findings. And then moving back to the initial concentration, the ultimate goal of this research is to know whether the micrococcus species is mercury reduced bacteria or not. And my answer is the presented result. It's likely yes. So to the best of analysis, this is a very first study to recognize the micrococcus species as mercury bacteria. And also this is one of the very few studies conducted regarding the mercury bacteria from the Antarctica regions. And as a recommendation, the first is to repeat the experiment on the mercury reduction, which is an experiment 2 because there are some inconsistencies of data. And the second is to test the mercury reduction on mercury containing wastewater, which will give you more the practical capability of micrococcus species on mercury reduction. And the third recommendation to further investigate the characteristics of micrococcus species, such as the growth curve and how much temperature they can tolerate. Yeah. That's all for the presentation, and here's a reference. Thank you.
Thank you for your presentation. It's very clear. My question is regarding the mercury reduction rate. In the methodology, what exactly the methodology that you followed? The third objective.
Third objective. Oh, the third objective is initially was not including my objective because initially I was not sure whether they can be used. And I conducted 2 experiments, which is the MIC analysis, and second is the reduction capacity. And the third, so now I can know that they can be used, so I did one objective to conduct a regression analysis based on the second results.
You did a regression analysis to check whether there is a reduction in mercury.
Yeah, so
I saw 4 samples were there on the regression line.
Yeah, this one.
So total number of samples is 4.
I have the control, but yeah, main sample is, yeah.
There are 4 samples, 1 country. Is it correct?
Yeah, at the concentration.
At that concentration.
Yeah.
So, what's the mercury concentration? This one?
Yeah, so this one is the
y-axis.
y-axis mercury reductions by milligram per. So this is the first, second result is a reduction by percentage.
Yeah, this one is a reduction per percentage, correct?
And this is the reduction by concentration.
You're expressing the concentration and percentage. It's going to be the same, is it?
It's a big difference because if you measure the reductions, it should go down by common theory because there's a more bacterial inhibition. Let's say like 100 milligram per liter, 60% is 60 milligram per liter. But if I say 200 milligram per liter, and the 40%, it will be the 80 milligram per liter. So it will be the different strength.
Yeah. So once after this is perfectly done, well answered. So once the experiment is over, regarding the expression of the gene itself, so we have identified in the previous study that there is a gene involved, which actually represents the mercury reduction stuff. So after your experiment, did you save some samples for further analysis on gene expression? Because you have experimented it on different conditions, so what Jeff has suggested you. Did you save some samples for further analysis on gene expression?
I didn't. I have the micrococcus species, but I didn't save this sample for the.
You missed it.
But there's like a potential to analyze, such as the in the first finding I found there is a precipitate, so one potential to do chemical analysis on this compound, so I can know that whether it's mercury sulfide or potentially it's a bioabsorption of the micrococcus species. So, yeah.
No problem. Thanks so much.
Mr. Gobe, could you go back to your problem statements, please? Okay. Do you intend to do your master's, Mr. Gobe? Masters?
Masters?
Do you
I am planning to, but
You're planning?
yeah.
Okay. Now, problem statements in the study should be specific to the study. This is still the background, okay? Each objective should have one prior problem statement. So each problem statement needs to be specific enough in that it leads to the objective. And when you get to the conclusion, each of the conclusions should answer the objective. Okay, this is too general. Okay, this falls under background. Now could you go to your objectives, please? Right, so to determine mercury tolerance capacity of micrococcus SP, therefore, I think it should be to determine the mercury tolerance capacity of micrococcus isolated from Stickney Island, Antarctica. So in this case, we can induce that the problem statement is the mercury tolerance capacity of micrococcus isolated from Stickney Island is still unknown. To assess the mercury reduction capacity, so the problem statement would be the mercury reduction capacity of micrococcus isolated from Stickney Island is still unknown. To determine the reduction rate, blah 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 blah. Yeah. So understand each problem statement is specific, which will lead to your objectives.
So it's better that I make it more specific.
Yes, for your future, in case you need to do masters or PhD. Okay?
Yes.
Okay, that's all. Thank you, sir.
Thank you, sir. No clapping hands, finish.